in this presentation, let's have a look at how do well systems work? What are the parts that make them work? All right, here we have a very basic well system. Let's start out with a well. A well is a hole in the ground where we can pull water up out of the ground for use. A shallow well is a well that doesn't drill in very deep. These are about 50 feet deep or so. From the well, the water is brought up into the house using a pump. The pump pulls that water in and feeds it to the fixtures. However, we also add a pressure tank. The pressure tank is basically a storage tank so that the pump doesn't have to be running all of the time. Without the pressure tank, the pump would have to run every time we turn on a faucet. This overworks the pump and they don't last as long. Pumps are expensive, so by adding a pressure tank, we can hold an amount of water that can feed our fixtures when we need it, and the pump just comes on and off as needed to refill the tank. Now every system is going to need a pump, and if the pump is accessible above ground, that makes it a lot easier to maintain. But in some systems, particularly a deep well system, that pump is going to be all the way down inside of the well. This is called a submersible pump. And the advantage to that is that it can draw water and push it up out of the depths a lot better than a pump that is up above, trying to suck the water out of the ground. Let's have a look at the pressure tank. This is the tank that stores water so that the pump doesn't have to run all of the time. Inside of the tank, there are two chambers that are separated by a diaphragm. The bottom chamber is water. This is the reservoir that the pump pushes into. It stores the water and then pushes it back out to the house. The top chamber is full of air, and this is compressed air or pressurized air. That air is what actually forces the water out of the tank and into the building. The diaphragm is allowed to flex back and forth. So when the pump turns on, the diaphragm flexes up and it compresses the air inside of the tank. The pump shuts off, and then we open a faucet and water starts running, and the diaphragm starts to flex down. The air is pushing the water out of the tank. So this cycles back and forth within the tank, water coming in and compressing the air, air pushing the water out, and this allows for a continuous water flow for us at the fixtures. Let's have a look at this important control T that is installed very often with the tank. You can install these components separately, but there is a T fitting that connects all of these together. It's the ideal for installation. In any case, these are things that you must have connected with your tank in order for this to operate correctly. First of all, we have a pressure switch. The pressure switch is an electric switch that turns the pump on and off according to the pressures in the system. When the pressure in the system gets low and the air has forced the water out of the tank, then we have what is called cut in. This is when the power turns on to the pump and it starts pushing water back into the system and refilling the tank. This typically happens around 45 psi. When the pump has refilled the tank and we hit the high pressure end of our system, then we have what is called cut out. This is when the power shuts off to the pump and our system is full. This is usually set to around 65 psi. What this means is that the well system pressure will vary between that low end of 45 psi and the higher end of 65 psi. At the fixtures, most of the time, people can't really tell the difference, but it is constantly fluctuating back and forth between these. The pressure gauge is there to indicate what the pressure is within the system. This way you can see what is happening as the tank is refilled by the pump. You see the pressure go up. As we use water at a fixture, you'll see the pressure go down, and it should turn on and off at those certain set points around 45 psi on the low end and 65 psi on the high end. There's a safety switch. This is the pressure relief valve. It is intended to relieve the pressure if things get out of control and the pressure goes too high. And we also have a drain valve. The drain valve is essential for maintenance. If you ever need to replace the tank, you really need to have a way to drain it down. Now, one other important note. When it comes to the air in the tank, that air pressure has to be set to 2 psi below the cut-in pressure. That means if we have a system pressure of 45 psi, it would need to be lower than that. If it's higher than that, we're going to have problems with the pump. because the pump will only come on at 45 psi. Also, when setting the air pressure for this tank, you have to do that when the system is off. Water pressure would give a false reading at the air valve on the air tank if the system were still on. So you shut off the water to the system by turning off the power, then you drain down the system, opening a faucet until it goes to 0. Then you adjust the air pressure within the air tank, and then you turn the system back on. This has been a very basic explanation of the way that a well system works and some of the essential things that a plumber should know. Obviously, on the electrical end, there's a lot more to know, and we should leave that to electricians. When it comes to digging the well or setting up the well or installing a submersible pump, sometimes plumbers may get involved, but most of the time there's contractors that handle all of that side. What we need to know is how the system works in relation to the house or building. And so understanding the tank, understanding the valves and pressures, and the way that those work is the basics that you need to know as a plumber. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching.